All right, so I just thought I'd be better off starting the video right with your module. So we're right on the same page as your module, and I can kind of go through the expectations. So, first of all, happy Tuesday and happy Halloween. So, the first thing that you're going to do today is your warm up. If you look at your Unit 4 note packet, you have a warm up, and I built a warm up into each one of our lessons, I believe. So for this warm up, you are just graphing each equation. Probably the easiest way to graph these, I would say for the most part, is to solve for y. And I try to abbreviate that on all of our notes. So solve for y. If you solve each of these for y, remember that you can graph your slope and your y-intercept. And then we're going to jump right into the lesson. Today's lesson is on graphing systems of equations. All right. So what is a system? Well, a system is when you have two or more. Oh my goodness, my OneNote just quit. Hang on one second. So a system of equation is when you have two or more equations with the same variables. So two or more linear equations in the same variables is known as a system of linear equations, a system of linear equations, or simply just a linear system. So you'll see in this first example, I have x plus 2y equals 5 and 2x minus 3y equals 3. So a solution of this system, so we're going to talk about a solution. A solution of a system of a linear equations is an ordered pair. It's an XY ordered pair that satisfies both equations or all equations in the system. All right. So we are solving our equations using graphing. It's probably my least favorite method to solve a system, but it's probably one of the easiest. So we're going to do a couple of different things. Number one, we're going to solve for y on some of them, on some of the equations. But on some of the equations, I'm going to use the cover-up method because I want to remind you of the cover-up method. So equation, this number one, solve for y. I'm going to change that to, for equation number one, we're going to use the cover-up. So remember, the cover-up method is just the intercepts. X plus y equals -2. So I'm going to use the x and the y-intercept. So if I want to find the x-intercept, I let y equal 0, and that gives me x equals -2. So that's the ordered pair -2, comma 0. I just covered up the y. And if I want to find the x-intercept, right, or sorry, the y-intercept, I cover up the x, and that's the equation y equals -2. So that's the ordered pair 0, -2. So I solved my first equation using the cover-up method or the intercepts. And I'm going to go ahead and graph those just so you can see them. So I'm going to graph this first equation on my graph to the right in green. So I'm going to go to -2 on my x-axis, and I'm going to go to -2 on my y-axis, and those are my two ordered pairs. And I am going to connect the points. Nice straight line. All right, so this is the equation x plus y equals -2. So for this second equation, I'm going to solve for y, SFY, solve for y. So I have the equation 2x minus 3y equals -9. I'm going to subtract 2x from both sides. -3y equals -2x minus 9. Divide every single term by a -3. And that gives me y equals a negative divided by a negative is a positive. So y equals a positive 2/3 x, and a -9 divided by a -3 is a positive 3. So remember my slope, 2 over 3, and my y-intercept, positive 3. This is the y-intercept, B. B is where I begin. It has not been that long since we did graphing linear equations. So I'm going to begin at 3 on the y-axis, and then I'm going to count my slope up 2 over 3. I'm going to plot a point. I'm going to do that again, up 1, 2 over 1, 2, 3. And remember, if I cannot go up 2, I can always go down 2 and to the left 3, down 2 and to the left 3. And hopefully you notice something interesting. Hopefully you notice that our two lines intersect, and that point of intersection is that highlighted point right there. That is the solution. That is the solution. So the solution to the system, remember it's an ordered pair, and this is the ordered pair negative 1, 2, 3, positive 1. This is the ordered pair negative 3, comma 1. So let's talk about what that means. And I see that there's a box down here for my solution, negative 3, 1. So what that means is the ordered pair negative 3, 1 works for both equations, means it makes it true. So I'm going to check the ordered pair negative 3, 1, meaning I'm going to substitute in a negative 3 for my x and a 1 for my y, and I'm going to see if I get a true statement. Negative 3 plus 1, well, that's negative 2, and negative 2 does equal negative 2. So that's true for the first equation. When I check it for the second equation, I am checking the ordered pair negative 3, comma 1. So 2 times negative 3 minus 3 times 1, that equals negative 9. And 2 times negative 3 is negative 6. Negative 3 times 1 is negative 3 equals negative 9. And negative 6 and negative 3 does in fact equal negative 9. So this is good. So I've graphed my system and I've checked it. All right. So let's talk about a little bit of vocabulary. So we have 3 types of solutions. These are the types of solutions or types of systems. So consistent, independent. Consistent, independent. Well, that's 2 lines that intersect. So if they intersect, that means that their slopes have to be different. If they're going to intersect, their slopes have to be different. They could have the same y-intercept. They don't have to, but they could. They could intersect at the y-intercept, so they would have the same y-intercept, just different slopes. So consistent and independent. Well, that's this first graph right here. And it says that these have exactly one solution. And you see that they have exactly one solution because their point of intersection, there's only one spot where those 2 lines intersect. Okay. The next type of system that you have is a system that is inconsistent. And this is made up of parallel lines. This means that they never intersect, right? So there's never going to be a solution at all. So this is the equation, the second set of ordered pairs. And you see that if it's inconsistent, it's no solution. And just like I said, you have 2 parallel lines. And then our last type of system is consistent dependent. It's a consistent dependent. And for that, you have 2 lines with the same slope and the same y-intercept. Same slope and same y-intercept. And what happens is you actually have 2 lines here, one right over the other. You actually have 2 lines, one right over the other. So the lines are actually stacked on top of each other, which means that you have infinitely many solutions. This is a consistent dependent. So I thought it'd be good to give you a couple of examples. So for consistent independent, it could be something like y equals 2x plus 4 and y equals negative 2x plus 4. Both of these equations have a y-intercept of 4, but one has a slope of positive 2 and one has a slope of negative 2. When we talk about our our inconsistent, that means these lines are parallel. So they have to have the same slope but different y-intercepts. Parallel lines have the same slope but different y-intercepts. So how about y equals 1/3 x minus 2 and y equals 1/3 x plus 7. That's an example of inconsistent. Notice that these have the same slope. Okay. And then our last example, well, that's something like 2x plus 3y equals 9. And the equation y equals negative 2/3 x plus 3. Two very different equations, but they're actually the exact same equation. If you were to take this equation and solve it for y, you would get the same slope and the same y-intercept. Okay? So now we are going to continue solving. And remember, this whole lesson is to solve by graphing. So every single one of these, we are going to solve using graphing. So I'm going to look at equation number 1. And for equation number 1, I'm going to use the cover-up method. So I have negative x plus y equals negative 7. So if I want to find the x-intercept, I let y equal 0. So I'm going to cover up the y. And that leaves me with the equation negative x equals negative 7, which means positive x equals positive 7. So that crosses the x-axis at the ordered pair 7, 0. So now I'm going to use the cover-up method to find the y-intercept. So I have negative x plus y equals negative 7. And if I want to find the y-intercept, I'm going to cover up the x term, right? Cover up the x term. And that just leaves me with the equation y equals negative 7. So when I let x equal 0, y is negative 7. So I'm going to graph those sets of points first. So I have the ordered pair 7, 7, 0 on the y-axis and negative 7, 0 on the x. Sorry, I said that backwards. 7, 0 on the x-axis and negative 7, 0 on the y-axis. So this is my line that represents that equation. Now let's look at the next equation. So equation number 2, I'm going to solve for y. X plus 4y equals negative 8. And I could do this one using the cover-up method. I'm just trying to show you multiple ways, right? Remind you of things that you learned in the past. So I'm going to subtract x from both sides. I'm trying to solve for y, get y all by itself. So 4y equals negative x minus 8. Next, I'm going to divide every single term by 4. So y equals negative 1/4 x minus 2. So my slope is negative 1/4, and my y-intercept is negative, my y-intercept, b, is negative 2. Now remember, I begin at b, so I'm going to go to negative 2. That's where I'm going to begin. And then I'm going to go down 1 and 1, 2, 3, 4 to the right. Down 1, 1, 2, 3, 4 to the right. I could also go up 1 and 4 to the left. So this is my second equation. And you'll see that my solution is this highlighted ordered pair right there. So my solution is the ordered pair 1, 2, 3, 4, negative 1, 2, 3. It's the ordered pair 4, negative 3. All right, so let's look at our next example. So this is already solved for y. My slope is 1/2, and my y-intercept is -5. So I'm going to begin at -1, 2, 3, 4, 5, and then up 1 over 2. My slope of 1/2. Up 1 over 2, up 1 over 2. I could also go down 1 into the left 2. So this is y equals 1/2 x minus 5. This next equation, I can definitely use the cover-up method for this. I can use the cover-up method. So when I use the cover-up method, I have 2y minus x equals 4. Well, if I want to find the y-intercept, I cover up the x, and that leaves me with negative x equals 4. Divide both sides by -1. X equals -4. So that's the ordered pair -4, comma 0. When x is -4, y is 0. Again, I can use the cover-up method. 2y minus x equals 4. And if I want to find the y-intercept, I cover up the x term. And that leaves me with the equation 2y equals 4. Divide both sides by 2. Y equals 2. So that's the order pair 0, comma 2. So 0, comma 2 right here. And my slope on this, let's see, I go up 1, 2 over 1, 2, 3, 4. 1, 2 over 1, 2, 3, 4. Well, let's see, 2 over 4 is the same thing as 1/2. And hopefully you notice that your lines are parallel. Hopefully you notice that your lines are parallel. So this is no solution. This is no solution. These lines will never intersect because they have the exact same slope. Okay? They will never intersect because they have the same slope. All right. So this is a your turn. This is a your turn. So I'm going to give you some hints. I'd like you to pause the video and solve this. This one, I would like you to solve for y. I would like you to rewrite this equation and solve for y. And then this one, I would like you to use the cover-up method. So I want you to go ahead and pause your video. Pause your video. I'm going to go ahead and do these, but I'm going to hope that you pause the video and solve for y for equation number 1. Use the cover-up method for the next one, and let's see what you get.
The picture it might be too cold.
Okay, I'm making a video. Yeah, I'm just working it out. Okay, so in our first example, when we solve for y, when I solve for y, I am going to add x to both sides, and then I'm going to divide every single term by 2. So y equals 1/2 x plus 3/2. That means my slope is 1/2, and my y-intercept is 3/2, which is the same thing as 1.5. So I'm going to go to 1.5 on my y-axis, and then from there I'm going to go up 1 whole over 2. I'm going to do that again, up 1 whole over 1, 2. I could also go down and over 2. Down 1 and over 2. So this is what that first equation that you solve for y is going to look like. The second equation, where I use the cover-up method, I have the ordered pair 2, 0 on the x-axis and 0, 1 2, 3, 4 on the y-axis. And hopefully you can see that these go exactly through this ordered pair. So your solution is the ordered pair 1, 2. So my solution is the ordered pair 1, 2. Now I want to check this because I want to make sure that we've done it right. So I'm going to do the check. Checking 1, 2. So x is 1. So I have negative and then x, which is 1, plus 2 times 2. And that has to equal 3. Well, negative 1 plus 4 does in fact equal 3. And when I check it for the second equation, I have 2 times x, which is 1, plus y, which is 2, and that should equal 4. And 2 times 1 is 2, plus 2 more is in fact 4. So that checks good. So last example, I think this is your last graphing example. So for this one, I think that we're going to use the cover-up method. So x equals 5 and negative y equals 5. Divide both sides by negative 1. Whoops, negative 1, not negative y. And that gives me y equals negative 5. So that's the order pair 0, negative 5, or 5, 0. So these look like this. That has a slope of 1. And then this equation, I'm going to solve for y. And I'm going to do that by subtracting 3x from both sides. So y equals negative 3x plus 3. My slope is negative 3 over 1. And my y-intercept is 3. Positive 1, 2, 3. I'm going to go down 3 over 1, down 1, 2, 3 over 1. And I already see my point of intersection. So the solution is the ordered pair 1, 2, negative 1, 2, 3. 1, 2, oh my goodness. It's the ordered pair positive 2 and negative 3. When I check this, remember I let x equal 2 and y equal negative 3. So x, 2, minus y, which is negative 3, equals 5. Well, minus a negative becomes a plus, and 2 plus 3 is 5. That works. And for the second equation, 3 times 2 plus my y, which is negative 3, equals positive 3. 3 times 2 is 6. 6 minus 3 is, in fact, 3. So we're batting 1,000. That's how we do that. So for this last example, this very last example, you have to determine which system is going to work based on this scenario. So Parks and Recreation Department in your town offers a season pass for $90. So you can buy a season pass for $90. If you have a season pass, so a season pass holder pays $4 per session to use the tennis courts. Well, there's that word per. And remember when we see the word per, that's our slope. So the total y is going to be $4 for every session when you pay $90 for your season pass. So this is the equation that we're going to use for the cost of tennis with the season pass. This is with the season pass. Okay. Now, it also says that without the season pass, so without paying that $90, you pay $13 per session. So that word 13. So that means that the cost without the season pass is just $13 per session. So this is the cost without the season pass. Right? So the question is, which system of equations can be used to find the number of sessions for which the total cost y, including the cost of the pass, is the same? So I'm looking for the equation y equals 4x plus 90 and y equals 13x. And that is equation choice C. Y equals 13x and y equals 4x plus 90. Okay, so I'm going to go to your homework. I'm going to go to your homework and I want to make sure you understand. So questions 1 through 8, you're going to solve each system by graphing. So after you graph each system, you are going to have a solution written as an ordered pair. For each system, you're going to have a solution. Remember that x equals a number is a vertical line, and y equals a number is a horizontal line. Okay? Things that you might have forgotten. Remember that every single solution, every one of these systems is going to have a solution that is an ordered pair, an x and a y value. So numbers 1 through 8, you're going to solve by graphing. So you can either solve them for y, write them as y equals mx plus b, or you can use the cover-up method. For questions 9 and 10, you're going to have to write an equation, and then you're going to have to graph it. Now you can, for questions 9 and 10, I went ahead and put a graph here for you, but you can graph it in Desmos first to help you. You can graph it in Desmos. A couple of things that are important. Number one, I want you to make sure that you label your x-axes and make sure that you write out your two equations for your system. So I'm going to get you started on number 9. Gabriella and Dan each improved their yards by planting ferns and geraniums. They bought their supplies from the same store. Gabriella spent $136 on 4 ferns and 8 geraniums. Dan spent $96 on 8 ferns and 6 geraniums. So if I let X equal the cost of a fern, because that's what it's asking us, what is the cost of one fern? And let Y equal the cost of a geranium. And I want to think about Gabriella's equation. So Gabriella bought 4 ferns and 8 geraniums, and she spent a total of $136. Dan bought 8 ferns and 6 geraniums, and Dan spent a total of $96. So again, remember I said you can use Desmos. So you're going to graph in Desmos. So Desmos will show you the point of intersection, but it'll also let you know that you can use the cover-up method for both of these, so you'll get the x and the y intercepts. Okay? So that should help you out. Now, I will be back on Wednesday. So on Wednesday, the first thing that we're going to do is a warm-up, and then I'm going to check to make sure that you filled out your notes for today and that you completed your homework. All right? I want you guys to be on your best behavior, and I appreciate you. Thank you so much.